All right, we have started recording. We are week 3, day 4, continuing on lectures on inheritance, or sorry, in object-oriented programming and classes in Python. Um, we've covered kind of how to create a class, how to add attributes and methods to those classes, also the difference between class attributes and methods and instance attributes and methods. And today's lecture is going to build upon those fundamentals and kind of look at one of the most important things about classes. We covered this a little bit when I was asking for a review, like kind of what is a class, and somebody said it allows inheritance. Now that might have not been something that other people grasped at that point because we hadn't gotten there yet, but the reusability of these classes and the ability to kind of keep our code dry is what makes classes very appealing and to use in our applications. So today we're going to kind of look at how this concept of inheritance works and why we want to use that with our classes. We're going to For this one, we're going to follow pretty closely to the README. It's a very good example of how these work. So let's start off with just looking at our classes. We're going to make a couple of classes that I'm sure we've made several times in other class and other lectures before, but we're going to have a dog. And you know what? I'm just going to copy and paste this to save time. We could type it all out, but we're just going to work under the assumption that we're all pretty confident on creating our classes with our init method, which takes in our attributes and assigns them. And then we can have other methods underneath, right? So here I have two classes. I have a dog and a cat. Right off the bat, it looks like they're two different things, right? We have a name and breed here, and then we have like a returning woof for the sound or the bark. Down here we have name and color, and returning like a meow for a make sound. So it kind of seems different, but then again, when we think about it, these two aren't all that different from each other. We can already see at least one thing that's for sure duplicated between these two classes. Like what's one thing that sticks out to you that we've typed several times, or at least two times within these classes?
The init function.
The init function, what specifically in the init function have we identified twice? Because we do, with all of our classes, we are going to have an init function, right? That's how we set them up. So we have to definitely have this. We have name and color from Adam. So I don't see color up here in dog, but I do see, yeah, I mean, self, that's always our object, but name, that is absolutely one thing we have repeated between these two, right? The dog has a name that we're passing in and assigning to a name attribute, and the cat also has a name that we're assigning as a name attribute. So right away, I do see we're doing name twice. We're typing out within our inits name multiple times. This also, these methods, pretty similar, right? I think with some tweaking, we could probably make these methods identical because this is just returning the sound each of these make, right? So we're seeing some similarities between these two. So this is where we start thinking about using this new concept of inheritance, because there are some things that are repeating in these, and I believe we can make kind of a more generic template that both of these can work off of. So what kind of is a more generic kind of class that these two would probably fit under?
Animal.
Animal, yes. We have a cat and a dog. They're both animals, right? So we have kind of a more generic class of an animal that we could probably give a name to and maybe some other stuff that the dog and cat could inherit from that class. So we're going to make this parent class that we can in turn give some of these repeated attributes to these children classes. So let's go ahead and I'm gonna copy these out so we can just have them on screen and kind of see. We're not gonna use them next here, but let's make an animal class. So it's very generic. It has a name as well. And now we take in also a species attribute. So every animal can have a name and a species assigned to it.
Mhm.
So now we are going to inherit in the dog and cat class this animal class and kind of build upon that. How you inherit something, and when I say inherit, I want to make it so that these individual classes I'm about to create can have access to all these attributes that this class has. Because if it's a cat, realistically, it should be able to have access to everything that an animal has, right? Because a cat is an animal, 100%. So, well, we'll start with dog first. How you inherit is it's like calling a function or a method. You're going to pass in the name of the class that you're going to want to share attributes and methods with. So I'm going to say this dog is going to inherit everything from the animal class. Okay, so now this dog has access to everything in the animal class. However, we still have to initialize everything. We have to initialize things that we are going to make specific for the dog, but then we're also going to have to initialize all these attributes in the animal class that dog now has access to. So let's one step at a time. Let's initialize our dog first, okay? We're going to set it up the same way we always do with our init. Oh, when I push tab, look, VS Code did something for me. And this is on the right path of what we're going to do. Threw in this extra line here. We'll take a look, though, at that in a second. Let's just focus on this top one, our init method for our dog class. So we already decided that we want the dog to have a name, right? And now instead of species, let's take that out. I don't want dog to have a species. I'm going to do I want dog to have a breed, okay? So these attributes up here in the init are specific to our dog class. However, this name, we're actually going to inherit. We're not going to set it up in this class because that's a lot of rewriting, right? We've already wrote it up here. We've got something in this animal class that says take in a name and assign it to this attribute within this object. So we've already got name in this one. I don't want to make another thing down here where I don't want to do this again. That's the point of inheriting. Don't want to do that again. So instead, we call a super init. So anytime you inherit from a different class, you need to initialize the super. And the super is just any class you put in here to initialize. Okay, so when we initialize animal, what attributes, parameters does it expect to get passed in to assign to the attributes?
For animal, just yeah, name, species.
Name and species, correct. So when we're initializing animal, it expects name and species. When we initialize down here within this other class, the super is going to say, look at this class I've passed in and initialize it. So it still expects all of those attributes to be passed in as parameters. We do not have to pass in self, though, because this is a different class, not this dog class. Okay. but we still need to pass in a name and species. We are
I'm
going,
sorry. My bad. I didn't mean to cut you off.
yeah, no, go
Can
for it.
you explain that last sentence you said about passing in self again?
Yes, so self is just referring to the specific instance of this class, right? So with dog, that's going to be self within this method. With super, we don't want to reference self because
Got you. Okay.
we're not worried
I
about
thought.
dog
Oh, okay. I thought you were saying you didn't have to put self within the init, but you're saying within the super. We don't have
within
to
the
put self.
super. Yep, yep.
Gotcha. Okay. Okay.
The super is pointing towards this other class we are inheriting from, and we can see it already has self and it's in it, so we don't have to do anything for self down here. We're just initializing this class object, basically. Um,
So then my question is if we're already doing the init method there on under class dog, well, is it not already pulling the init from class animal? Or you have to put in super for it to pull?
yes, that's the correct statement there. You have to put in super for it to pull from the class you're trying to inherit from. If
Okay.
you do this init, this is just for this specific class. The syntax to
Oh,
this
okay.
class initializes and calls this init method is using this super.
So when we do the instance init under class dog, I see that you have name, but do we have to put name in? Once you do the super init, you can take it off, right? Am I jumping ahead? My bad.
So you still need to pass it in. So we are basically, instead of typing all this out twice, we're just going to take a shortcut and say, hey, this class already has it. But we still need to pass in those values because the point of this is that we'll have access to these attributes in this other class we're inheriting from, but we still need to provide values to be assigned for these
Okay,
attributes.
I see. I think I see what you're saying. You still have to have the blueprint for
Mhm.
it to land in. Like you still have to have that room for something to fall into, or that bucket has to exist for it to, I guess.
Yeah, I think it'll become more clear once we start using an example of how to, like, when we start initializing these classes, or
Okay.
instantiating an instance of these classes. I think it'll be more clear there. Just hang on and see but definitely interject with more questions, if you're still trying to. It
Okay.
is kind of a difficult concept to wrap your head around this initializing of dog and then initializing the parent class you're inheriting from. Um, we still, the goal is to still do dog one um, equals dog and then pass in name and breed, right? The goal is to still do this. Uh, what's something I can spell? Because I want to do dachshund, but I definitely think I will mess that one up.
Labrador.
Husky.
Oh yeah, husky. Yeah.
So we still want to create a dog and give it a name and breed. However, we're inheriting from a class that's already identified and set up these attributes for us. Um, so I'm not going to list down here self.name equals name. I'm going to actually pass it into this super initialization, which will cause this or call this initialization method. And we'll take that name then that we pass in and assign it as a name attribute.
If you have overlapping um, instance attributes, does one override the other? Like you have name in both?
So anything I pass in here is not going to be the name of the attribute up here. It's going to be the value that I'm passing in to use in this initialization method.
Got it. Okay.
So I am going to pass in name. So it's going to be identical between the two. However, it's just saying use the value that you're passing in for this dog name and go ahead and throw it in the initialization method for animal as name. Because animal initialization method expects name and species. Okay, so we're going to pass in the name. Now, breed, animal doesn't have a breed, right? So I'm not going to pass breed into animal into the animal initialization because it can't handle that. It can only take name and species. So I'm not going to mess with breed right now. We're going to do that in a minute, but we still need to fully initialize animal here, and it expects the species. Since we're making a dog, I'm just going to go ahead and give it a default species. Okay, so now I am initializing animal with a species equal to dog. So I will have a name attribute. This name attribute that we're taking from animal can still be referenced within dog as self.name. Okay, it's just a shortcut to not type this out in every single class you're creating. But you can still access it the same. This dog, you will still be able to do dog1.name, and it should print Fido. I'm not
So
gonna go ahead.
oh no, my bad. So I kind of see the super init being like the connector between between the instance and the class. Is that right? Like it's like the translator. Like, hey, this means this for the class of us.
Yes, exactly. For the parent class, it is definitely 100% the connector between the two. Without the super init, we can't really do anything with items in this class.
Okay. So if you create a class or if you create another class that calls upon another class, am I saying that term right? Is it a subclass? Or I guess
Uh,
if you create it or what with it, okay, so if you create a class within a class, you have to have a super in it for it to connect the parent class.
if you're inheriting, yes. This
If you're inheriting.
afternoon, we're going to
Gotcha.
go into a different concept. It's going to add some confusion, but right now we're talking about inheriting all the attributes and methods from this class. So
Gotcha. Okay.
if I didn't have this super init, I would then just do self.name. I'd retype it out. Not on the... However, I am not on the right keys. We've already done it in this class, so that's why we're inheriting. So I'm gonna say now, like you might be looking at this like this is kind of dumb. It takes 2 seconds to type out self.name equals name. Why do we want to inherit attributes from a different class? The way this really shines is inheriting methods from a parent class. So we'll look at that in a little bit, but hang on. Uh, so I know this seems a little tedious right now, like we're typing just as much here, trying to initialize the parent class as we would have just, listing these attributes out. But we don't want to do that. We're going to do more with these classes that we want dog to have access to. Okay, so we've got our dog class. We're initializing our dog class here. We want a name and a breed passed in. So I did that name and breed. Then we're going to initialize our parent class that we're inheriting from, which expects a name and species. We did that here. We passed in the name we're taking in from initializing the dog class. And then we're just going to give a default value for all dogs to have species equals dog. But now we have this breed. Breed isn't something we're passing in to our parent class because it does not have any attribute that handles breed. So breed is specific to the dog class and the dog class only. I've passed it in. So now I need to assign it to an attribute within this class. So we're going to come down here and just tack this on. Self.breed is going to equal breed that we're passing in. Okay, so now what are all the attributes that dog has right now, including the inherited ones?
Name, species, breed.
Exactly. We have name and species from this one here, from right there. And then we have breed that's specific to dog itself. Does animal have access to breed?
No.
Nope. Nope, it does not. Animal cannot see this dog class. It's not doing anything with it. But dog can see everything within this animal class that we're inheriting from. All right, so now I'm going to make another method called bark. I don't know why are we doing this? I guess this afternoon we're going to talk about method resolution order. Okay, it's a very basic introduction right now before you work on your first challenge. This afternoon, we're going to build a little more on when I mentioned that methods are the true reason behind inheriting from another class. That's where this shines. We're going to dig deeper into that this afternoon. Just keep that in the back of your mind. Okay, so we have bark. That's return. I'm just copying and pasting. We're going to do that. It's too much to. Okay, so now dog has its, method that we wanted of bark. So we can do dog one, bark. Print that though, because it doesn't have a print statement within the method itself. And let's see. Let's take a look and make sure that this class is set up correctly inheriting from animal. So we've been initialized a dog here with the name of Fido and the breed of Husky. We should be able to print the name. Let's go ahead and also print the species to make sure that this inheritance from our parent class and default value are actually applying correctly. And then we're going to call this bark method. Now, again, is this bark method accessible by animal? No, no. Anything within the dog class is not accessible by animal. If I had a method up here, nope, not. Yeah, I don't know what I'd pass in here though, or what I'd do here. That's generic enough, right? So if I have a make sound method up here, I could call make sound. So everything this animal class has, dog can access the same way you would as if it was in its own class. So animal has a method called make sound that says I made a sound. Super generic because it fits for everything. So dog could have this I make a sound method. But then we've also created one that's definitely more specific for the dog animal called bark, where it will do a sound specific to dog. Okay, so let's go ahead and print out here. So we see definitely got the name Fido. We see the species is dog, which is what we've done as a default in our super init. And oh, I didn't print the make sound. I wanted to show that we get that still from the parent class. Okay, so we can see it accesses that parent class's method, make sound, says I made a sound, and it does its own method called bark. The super init is only for the attributes in the initialization with this parent class. You don't have to do anything special with all the methods underneath the parent class. You have access to them automatically without doing anything special here within your initialization or anywhere else in the class. And that's what makes inheritance really cool. So you can make a whole bunch of different methods within this animal class that make sense for all animals, and dog would have access to them. Okay, now let's get cat up here. I'm just copying and pasting cat. Do a few down. Okay, perfect. So cat, same thing, is going to inherit from animal. A cat's going to take in a name and a color. Like we have orange, brown. We could still pass in breed there, but they want color. So this initialization line is specific for our cat class. But the super init line underneath is for our parent class that we're initializing from, which again expects name and species as its initialization. So we pass in a name, and then just like we did with dog, we're assigning a default value of cat for this species. Color was something new. This is not in the parent class we're inheriting from. This is a new attribute specific to this cat class. So since it is new and not in the parent, we still have to initialize down here. So now cat also has access to everything within animal. So cat has these attributes as well as color. Cat can also use this make sound method as well as its own make sound method. We're gonna touch on this all right now because it's just set itself up for this. We'll dive a little more into this and see more examples this afternoon. But what the heck is going to happen here? I've got two identical methods in both of these classes. All right, the one I'm inheriting from, this parent class of animal, has a make sound method that says I made a sound. But then my cat class, I made the exact same name method, but had it do something else. It returns meow. What do we think will happen if let's initialize a cat real quick. If we call make sound.
It'll print out both of the sounds
We
because
think it'll print out both?
maybe because I'm only thinking because it'll look at the parent class, return that, and then go to the instance itself, that class of animal, and then do that function. Because I always try to remind myself that uh, it only does what it's told.
Yes. Okay, so logically, that sounds like that would be what it would do. However, this whole inheritance thing, and it's the technical term for it that we're going to be looking at here is called method resolution order. Ken put in the chat here that the child class for the method that we identify as the same name as the parent class will actually take precedence over whatever the parent class has. So when we run this, it's going to, well, let's just see what happens. So we thought logically it would go to the parent class, call that method first, and then come to the child class and call this. So let's go ahead and see cat make sound. Yeah, we'll see what it does. Okay, I think that's right? Okay. Well, it just put up meow. So this whole I made a sound, it's like it didn't even call it at all. And that is how methods behave within class inheritance. It's a very, it's an intentional thing. We want for our methods, whatever we identify within the class itself to be the default for running this method. So as Ken said, it supersedes the class one. And that is only with identically named methods. Okay, bark didn't supersede because it's named something different. But if we change this to make sound, it would, for methods only, it would look within the class itself and say, hey, dog, do you have a method called make sound? Oh, no, you don't. You have a bark. So then it goes to the parent after that and looks in there. Hey, do you have a method called make sound? You do. Okay, I'm going to use that one. So for cat, when I called make sound, it said, hey, cat, do you have a make sound method? Oh, you do. I'm going to return this. And then it's done. It found the method it wanted and it called it and it completed and it's done. So it doesn't go to the parent because it found what it was looking for within its own class. So does that make sense?
Yep.
See a few
Makes
more
sense.
examples this afternoon, but it's really cool. It's a really cool feature of inheritance in classes to really specify how you want certain things to act, but still grab some things from the parent class. Yeah. Okay. So any questions on how we set up these classes inheriting from another and how this super init works within our regular init? Okay, just to reiterate,
So,
oh, go ahead.
if you have a instance of animal and have a species value, then you wouldn't need to have it, or you could do it within the class animal, like, and not have to do it in the dog class. I don't know, or
Well,
you
so
know,
yeah, the classes and objects are weird out of these. These are just blueprints.
yeah,
When you instantiate a class, it's its own separate thing. So if we instantiated an object of animal or the class object animal, it would have its own name and species that are only unique to that instance
right.
of that object. It would not be seen by any other instance that we've created. So if I
Oh, okay,
had animal one
okay.
equals,
Oh, okay, that makes sense.
yeah, yeah. So it still took in a name. Okay, Bob, because we're very generic, and then we're gonna do a cat. Okay, so this instance of animal is not something we can pull from when making like an individual cat. But good question.
Yeah,
Um,
okay.
Any other questions regarding this?
When you write the same method that's also in the parent, can you also refer to that as overriding the parent method?
Yeah, I mean, you could definitely say that for sure.
Because I just have previous programming experience and we call it, I've always heard of it as overriding. So I'm
Yeah,
gonna,
I mean, that's what I say too. It overwrites the other class, but it's that method, the MRO of all these class objects. Okay, so we're good on classes, attributes that are for the individual class, attributes that are for the parent class, and how to initialize a parent class. Okay. Um, let's see. So now we're going to get a little more. Oh, okay. I have a different example actually than the README has because the README is a little misleading. Um, so with this example, both our dog and cat inherited from animal. Um, but you can also have multiple inheritance. You don't have to just inherit from one class. You can inherit from multiple different classes. So that's what we're going to look at now. Definitely gets a little more difficult. Okay, so the README does have one example here of a multiple parent-child relationship going on. It shows you a mother and a father class. These ones are not inheriting from anything because they don't have the parentheses and a class identified in there. These are just base classes. It also has attributes that are given a like specific value. So every time we initialize mother, the mother's just always going to be named Sandra Walensky. Same with father. Very specific attribute values. This child is inheriting from both of those. This is misleading. This only works when you have attributes that are static values. If you're passing in names, you cannot just call the parent class initialization. Okay, so this example is a good kind of rough idea of how you can inherit from both mother and father. It's going to initialize these two classes within this child. And it's basically going to set the child's name as Benjamin, and the last name is going to be, let's see, we've initialized father first. Let's see, I actually don't know what, I think this is going to be the father's last name because that's the one that's initialized first. Or it might be the, let's take a look and see. We're just going to run this real quick. I don't want you to focus on this. I'm going to go through a different example. Okay, so it took the mother's because that was initialized second. So this shows how this child is inheriting from both these classes. It's getting these attributes from both classes. However, very rarely are you going to have parent classes with static attributes, right? That doesn't happen. The point is we want to be able to pass things in and initialize these classes with different values. So I'm going to use a different example of inheriting from two different classes. I am going to make a generic class here called vehicle. And for this initialization, we're not even going to pass anything in, and I'm not even going to have any attributes or methods within it. It's just going to be a vehicle class, okay? So when I initialize, it's just going to set this up as a vehicle, just to give it some structure on how we're going to set up the rest of these classes. So we have a vehicle. Now I'm going to make a car. Do we think car could be a type of vehicle? Yes, I think so. Car definitely sounds like it could inherit some things from vehicle. It is a vehicle, right? So this is a good way to kind of tease out if you want to use this inheritance on a class. If I can say car is a vehicle, then we can probably inherit from vehicle. Just like we said, a dog is an animal, so we can inherit from animal. So this car is a vehicle. We're going to go ahead and inherit from vehicle. We're going to set up our initialization method for our car. Okay, so it autofills for us our initialization line for car, and then our super initialization, which is targeting vehicle. So with a car, I am going to go ahead and say it has wheels. I'm going to default it to 4 because I mean, most cars I've seen have 4 wheels, right? So I'm going to give it a default value of 4. And that's going to make this example a lot easier too. This parent class, do I need to pass in any parameters to initialize with? First, somebody tell me what this what line 35 super init is targeting.
It's targeting the I guess the parameters of class vehicle, but there's nothing in it right now
Okay.
for the init.
So more specifically, when I call this super init, what exactly is it calling?
Oh, it's calling the vehicle parameters, so the init of the vehicle parameters, which right now we just have pass underneath it.
Right. So it's calling
So
vehicle init. Right. Correct.
yeah,
Yep. And like you said, it doesn't take in any parameters, right? Self is always in all of our methods within our class. Just ignore it. But after that, I have no parameters being passed in. So do I need to pass in anything into this initialization for our vehicle class?
for right now it'd be wheels.
What
Or I'm
does,
sorry, no, because that's specific to that instance. So right now, wheels unless you're trying to identify wheels in every single subclass, then no. But right now, it's just specific to the car instance.
Right, so wheels are specific to car. It is parent class does not have any wheels in it. There's no attributes called wheels. However, I still have to handle this attribute because this is something specific to car. So we come down here and do what we do and say self.wheels equals these wheels that we pass. Okay, cool. So I have a car there. Now I'm going to make a plane. Is this a vehicle?
Yeah.
Yeah, it's a type of vehicle. So let's go ahead and inherit from vehicle, especially since vehicle doesn't have anything limiting us. We're just using it as kind of a classification here. So plane will inherit from vehicle. We'll go ahead, excuse me, and initialize. Now, instead of like wheels, let's pass in like wings. A plane has 2 wings, okay? Dumb example, but it works just to show the difference between these 2 vehicles. So again, the super init is targeting our vehicle init, which doesn't take in any parameters for any attributes. So we do not have to put anything in here. It will be empty. However, wings is specific to our plane class, so we do have to set that up here as an attribute. All right, so we got that. Now what about that? Flying car. What does it sound like it possibly has attributes related to?
Flying
Plane.
cars.
There's a couple of people talking at once. Flying cars. So does it look like it can match any of these things I have so far? I heard a little bit, I think.
All 3.
All 3. Okay. So yeah, a flying car definitely seems like a type of plane and a car. Yes, exactly, Adam. It has wings and wheels. It's got both of those. Since these classes inherit from vehicle, I don't have to pass in vehicle as an inheritance class, but I do want to inherit everything from plane, and I do want to inherit everything from car because it's going to have wheels and wings associated with it. So here we could literally just pass in car and plane. We still will initialize like we do with every other class. And we're not gonna, you're being too helpful right now. Okay, so let's take a look at this. If I initialize, I don't have any specific attributes. Oh, good, Scott. I'm glad this is answering the question. I don't have any attributes I'm going to identify as new for this flying car. It's literally just a combination of car and plane. So I'm not going to have anything new being passed in this init method. The super init, I only have to call this once. I don't have to call this for every parent class I'm inheriting from. When I say super, it's going to go through each of these and call each of these initialization methods. So let's take a look at each of these initialization methods and see if we need to pass anything in. So super init, it's going to target car first because that is first in the list. It's going to work through in order. So let's initialize car first. The only thing it takes in is I could change the value of wheels, but it has a default value. So I'm not going to do that now. Also because that's going to make the example a little more complicated, which I will show you, but we're going to kind of just skim through it. Now, then after it tries to initialize that, which we don't actually have to pass in anything because it's defaulting to 4 wheels, it will go ahead and then call the plane initialization method. And again, it has a default value as well there, so I'm not going to pass anything in. It has 4 wheels and 2 wings. So that's literally all I need to do for flying car. So now if I were to make a flying car one,
Make it the fantastic car.
the what?
Make it the fantastic car. That's a flying car, right?
Fantastic car?
Fantastic car from the Fantastic Four.
Okay.
Yeah.
Can I just leave it all one word like that?
Yeah.
Okay. All right, cool. We're gonna lower staff though for okay. So yeah, we're gonna why does it seem like we're that's weird. It seems like we're
Yeah,
using
that's good.
okay, so now when I print Fantastic car, let's see. So we have access to all the attributes in these 2 classes we're inheriting from. So we can print wheels and we'll print wings and make sure that it has 4 wheels and 2 wings associated with this flying car. Okay. Awesome. Okay, so let's take a look. And we can see, hopefully it's not too low on your screens. When I did wheels, it did indeed inherit everything from car and initialized with a default value of 4. So our flying car has 4 wheels and 2 wings from plane. Okay. Any questions on this? You're not going to find yourself inheriting from 2 different classes often. So this is good to know. You're not in practice going to do this a lot.
I'm surprised Python allows you to do it because all the newer languages are not only allowing you to inherit one time,
Oh, okay.
and then you have to use interfaces for everything else.
Yeah, it's a pretty cool built-in thing. Let me show y'all now. So this works the way I've written this because I'm not passing in any parameters into these initializations here. If I wanted to, I guess, instantiate this flying car and pass in, let's see, wheels and wings as different values, we have to handle it differently. So let's see, I've got an example here. I'm just going to put the whole thing on the screen and we're going to walk through it because this is not, again, like I said, this is not something you're going to come across frequently because sometimes it's hard to find 2 classes that you can inherit from both of them. Okay, so here I've got basically the same thing. I've got a car and a boat this time instead of a plane. But in these initialization methods, I have an addition of something here. Quargs. Do we know what quargs are? Have we learned about quargs? Seen them?
Ooh.
You've seen them?
Is it the unlimited one? It's like an unlimited amount of arguments.
Yeah. Does anybody know what quargs stands for?
Keyword arguments.
Exactly. So this is kind of like a catch-all to basically accept anything that the user calls this initialization method with. So we've identified one parameter that we expect in this. We expect to get wheels, but then it says, you know what? Go ahead and accept anything else the user passes in as well. Okay, it doesn't limit it. And this is important,
Oh,
and we will see
quarks.
why. Sorry, what was that, Brian?
Oh, nothing. I was
Okay.
thinking out loud. Sorry.
Yeah.
When I saw it, I was like, quarks. What are you talking about? And I'm like, oh, when I saw it, I'm like, oh no, I know.
Quarks.
Yeah. It's a kind of a fun name. Okay, so then we can see also we do the same with the SuperInit. We go ahead and say for this vehicle class, which is, initializing with the super, we're going to pass in quargs to it. Now, the vehicle itself doesn't accept quargs. It just allows us to pass that in, but this one doesn't have it within it. Boat, we got the same thing. We're inheriting from vehicle. We've got propellers as specific to this class. But then we're going to accept different keywords as well being passed in, different arguments. When we come down to our amphibious vehicle, here we are inheriting from both car and boat. Okay, it's both of them. However, with this initialization method, we do see that we will take in wheels, propellers, and a name. Wait, I don't have a name anywhere. Oh, it's right here. That seems like it could be in vehicle. If I rewrote this, I would probably have name up here in vehicle and inherit and everything else instead of just specific to amphibious vehicle, but that's fine. I guess because I gave duckmobile. Anyways, tangent. So this initialization method actually does take in values, parameters. It takes in wheels and propellers and a name. Now, it's going to initialize this class with that first. So it's going to assign the name as an attribute specific to this class, but then it's going to take these other values and pass them in as parameters for the super inits, which are initializing our parent classes. What order does this initialize in, this super init? What parent class will initialize first when I call this? I can't read lips. Somebody tell me off cam or off mic or on mic, whatever.
It'll do it in the order of the classes you passed into amphibious vehicle.
Correct. Yep. So it's going to initialize, call this car init method first and then boat. So let's go ahead and take these two values that we're passing in as parameters for this super init and go to car with them. So we're going to try to initialize car with, we're passing in wheels and propellers. So that's where the issue comes in, because if I didn't have quarks, if I tried initializing with both wheels and propellers, it would come up to car and say, hey, take these wheels and propellers and go ahead and initialize. Car would say, whoa, 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 whoa. I can see wheels, but I don't know what the heck propellers is. But we need to pass that in to this one init statement, because when it comes to boat, boat expects propellers, right? So that's why we have quargs in here, because it will go ahead and accept propellers as an additional keyword argument. Doesn't do anything with it. It just kind of accepts it. It says, all right, I'll take that value and I'll do my thing with the rest of them, because we haven't identified any action it should take with these additional keyword arguments. So everything is fine now. It doesn't break. When we initialize with both wheels and propellers, it will do its thing with wheels. And we explicitly tell wheels equals wheels. And that way, when it's initializing, this car is initializing with those parameters, it can see 100% that wheels is going to equal wheels. Now, this wheels, where does this value come from?
It comes from the instance itself. So we're saying wheels equals whatever the user puts in there for
Yes.
the instance.
Very good. Yep. So this value that we're passing in for this initialization method is what is going to be pulled down here into the parent one. So that's this. This wheels is the value that the user puts in when they're initializing. Correct. Same for propellers. This is the value that the user passes in. These are the names of the attributes we're going to go ahead and apply them to in each of these classes. Okay, so superinit calls car first because that's first in line, passes in wheels and propellers. car can go ahead and identify wheels and assign it to this attribute wheels. And then it passes on to the next one because propellers it does nothing with. So then boat initialization method gets called. Now, can't do anything with wheels because both of these are still being passed in. However, we got that quargs, so it doesn't break. It will accept that as an argument and not break, but it doesn't do anything with wheels. It'll just go ahead and jump to propellers, which is handled here. We say, okay, propellers is going to be assigned to this attribute. So that is how you do inheritance, multiple inheritance with something you want to pass values in for, which is going to be the majority of the time. You need to just throw in this quargs in the initializations of the other classes. And then also it doesn't hurt to throw in this superinit here. Also because we don't, actually, I don't think it needs this here. Let's test it without it. Maybe it does. Nah, let's try it without it because this doesn't expect any parameters being passed in, so we can call this superinit without passing a value in. Theoretically, I didn't try this yesterday when I wrote this example, so we'll see if it breaks, and then we'll figure out why. It might just be a syntax thing where if you pass in, you have to with this. We'll see. But logically, I don't think it should break, and I think this works just fine because our vehicle does not expect any parameters to be passed in for attributes. Okay, so here, and then I've just got like a describe method underneath this to show that it's going to go ahead and properly assign these attributes as we pass them in. So I'm going to make an amphibious vehicle. It's going to have 4 wheels, only 1 propeller, and I'm going to name it Duck Mobile. And then I'm going to call this describe method, which will print this on our screen. So let's see if I broke it by taking out those super quark inits. I did. Okay. So I guess it is a syntax thing. I looked up in documentation. Now let's try. Yep. All right. My theory, like my logicalness, did not overwrite the syntax that Python expects with this. So if you throw in quargs up here in your initialization for this method, go ahead and throw it in the super init as well.
Could you, instead of using quargs, could you more explicitly like pass the instance, like instead just do like class dot instance attribute?
I don't, I'm not,
So
you mean,
like on line 68, instead of doing like like let's say you're passing propellers like to car,
mhm.
could you do like vehicle dot propellers? Or let's see, sorry, like boat dot propellers? Or is there no explicit way to like pull those? Do you know what I mean?
Yeah, so we could probably test it and write it out, but I don't think it'll work because that's kind of where this kind of is misleading. You can't do this. You can't identify the specific class
Oh, okay. Yeah.
with the
Got it.
init. It doesn't work like that because you have to do a super initialization for it to work correctly. I wonder. This is getting into past my knowledge, so I'd have to look into this, but I'm wondering if we can pass it in the super somehow. Super, it does say object any. So I wonder, well, let's test it out. Worst it does is throw errors on the screen and then we just go back to the way we know works. So let's maybe do it explicitly and then just pass in wheels. I don't know if this works. I don't know at all. But that's the good thing about it. You can just plug it in and try. So perhaps this works. But Python syntax can sometimes be very picky with how you work it. So let's see. I don't know. I don't know. Yeah, I didn't like that. Super argument must be type, not int. So it looks like you can't pass that in. There might be a different way to structure this. That's definitely something I would have to look into in the documentation.
For sure. No, I was just curious.
Yeah. And definitely something y'all are free to look into as well. This is just what I know works. And there's definitely more than one way to do things, obviously, and more advanced ways to do things. But even this itself is probably a little more advanced than you're going to get here. The previous example I showed where you're just initializing default values should be fine, as long as you understand what we did up here. And then this isn't that far off. You just gotta throw in quargs. Don't even worry if you don't understand why it works. Just throw in quargs. As long as you make sure to pass every single parent attribute in here and identify it clearly. And I will share this code because this isn't anywhere. I'll share both of these actually. I'll make a thread and put these both in there. Any classes, or sorry, classes, I'm reading class right now. Any questions on anything we've covered so far? And then we're going to take a break here in a second. But anything about inheritance between a parent and a child class, or the super init, or the keyword arguments, any questions? Or we think we're
Do you have to use super init if you
when
inherit?
inheriting from another class, yes.
It's required. Okay.
Because that is what calls that parent class initialization method. And there is, I don't know how helpful this is, but in the README on the very bottom, there's Python super method. And it kind of goes a little more into all the things how super works, how it works on single and multiple. There are a few typos and issues though in this article, so take it with a grain of salt, but it can go into a little bit more of a deep dive into that super function. Yeah. But if you don't want to learn about it, just learn about the structure. I mean, this is just how you're going to see it structured all the time. The class initialization, then the super init for the parent class. All right, any other questions? All right, I will stop recording. I'll pause recording because we have a two-part lecture today, actually. So let me pause. All right, picking up the recording again. We did a little practice on inheritance with our classes. Now we're going to be diving a little more into some of the things we already touched upon and kind of learning about some concepts and some names surrounding some of these things we've already looked at. So I'll pop up this example from the README. This is kind of what we've already learned about here. This is inheritance, right? We have a base class. These classes are inheriting from this base class. We've identified that this is kind of appropriate because we're saying that these classes are a version of this base class. That's how we're identifying our inheritance. If we can say this is the parent class or is A, then that's usually how we identify using inheritance. So of course we could say a rectangle is a shape. A circle is a shape. Our previous example, a dog is an animal, a cat is an animal. Okay, very clear cut, like it's a type of a parent class, and we can use things inherited from the parent class. So that is inheritance. There is another, I guess, structure? Nah, I don't know how to say this. Concept with classes that we could use, and it's called composition. So let's go ahead and build out kind of a few different classes here. We're going to make a class that's called engine. We're not going to have an init method for this because I don't need to, I guess I'm not going to pass in any attributes. It feels weird. I would still probably have an init just for good measure, just to not confuse ourselves. So let's have an init method, but we're not actually going to pass in anything to this. It's kind of just identifying an engine class. But I will give it a method that's called start so that this engine can start. All right. And we're just going to return engine started. Okay. So here's a class of an engine. Now I'm going to make a class wheel. So earlier we had wheel as an attribute for our vehicles. Like we had that for the car class, but really wheel can be its own object, right? It's a part of a car. It's its own thing, own separate. It's not, so it can be its own class. And we're doing that like division of, oh, I forget how this is phrased, separation of responsibility, I guess. No, what's the word I'm looking for? Separation of, I know somebody here knows it. I'm gonna Google it. I had the word on the
What are you looking for? Or
oh, go ahead.
Concerns.
Concerns, separation of concerns. Yes, there's a yeah,
I've never heard
okay,
of
I
it.
guess that is I think there's something specific for object-oriented programming. Let me look at the intro to OOP and see if we have the little intro here. Really, we don't. Wow, okay. But yeah, we'll say separation of concerns. When I Google it, that's kind of coming up here. Making sure that each design is responsible for its like a specific functionality. Like we're not including too many things into one object, that it's very separated, and it helps for testing. It helps for reusability in our code. There's a lot of different ways it helps. So wheel, we have this underneath our car instance, but really it can be its own class. It's its own object. It has its own attributes and its own way it's identified. So we're going to set it up as its own thing. Again, for a good measure, I'm going to have an init method just because I want y'all to never forget that init method, but I'm not going to actually initialize it with any attributes. It's just going to have a method underneath its class called rotate. I guess this is from the README, and it's just going to say the wheel is rotating. So it's just kind of describing what this wheel does. Okay, so we have two classes, an engine and a wheel. Now I'm going to make a car.
Real quick, and you might have already explained this, but under class pass, that's just a placeholder, or what is that specifically calling to ask?
Yeah, this just allows this method to just kind of exit gracefully without actually running, without a return statement. It can be seen as a placeholder. Usually you do put something in here. But we could just we can return just created as well. I mean, we could just put whatever we want in this init, I guess, but we're just doing pass because we don't need to put anything in here. So it will call this initialization method and then just not do anything in exit.
Got it. Thanks.
Yes. So a car. Now, we talked about inheritance. Is this car an engine? Like, can I say car is an engine? No,
Car is
no. And a car is a wheel? No,
no.
it's not any of these things, but a car definitely has an engine in it, right? And yes, it has a wheel, exactly. So it has both of these classes, but it's not a type of these. So this is where we use composition versus inheritance. I'm going to do my init statement here for this car class. And I'm not going to pass in anything right now, but I do want to identify some attributes it has. So this car has an engine, okay? And it has some wheels. So I am not passing in anything right now, but I'm going to go ahead and assign this engine. I'm going to make this an instance of this engine class. So I'm going to initialize an engine here. Now, what is this doing? When I initialize car and then it says, okay, this engine attribute is going to equal engine. What is this doing?
Just starts the engine.
Yeah, it initializes the engine class, all right? So when I call it like this is the same thing that we do down when we're saying like dog1 equals dog parentheses and then whatever attributes. Yes, it creates an instance of this engine class. So once we call this engine class to initialize, we don't pass anything into it, but it will have this, start method as a part of it. So engine will be initialized using this engine object, which has a start method inside it. It's not inheriting it. It's just making it equal to something in this car. So same with the wheels. We're not going to inherit anything from wheels, but we're going to say, so this has how many wheels? Does it have one wheel? Does a car have one wheel?
Usually 4.
Yep, 4. Okay, so it has 4 wheels. So how can I handle this? If I just put in wheel, is this going to give me 4 wheels? No, this is going to instantiate just one instance of wheel. So I want to say that this car has 4 wheel objects in it. And we say we can do wheel equals 4. If we had an attribute within this called wheel, and then we had like, it would probably be like number, num of wheel, Sure, we could do it like that, but we don't. We just, an instance of a wheel has nothing it's taking in. So what we can do is used some, I'm going to say this is list comprehension, but not really. We're going to create an instance of wheel for whatever in the range of 4. So what does this underscore mean? What am I doing there?
It's like an iterate.
Yeah, it's like a placeholder, right? We could put a name here, like a variable name. But we don't need to. We're just counting up in a range to 4. So instead of actually saying for like number in range of 4 or whatever. We don't need to specify that. It's not needed here.
But it's usually like an I for I in range 4, something like
Yeah,
that.
yeah, something like that. But since we're not actually using that variable name, we're just kind of using it to iterate through, we can just do this underscore, which kind of just means, hey, placeholder. Like we're gonna say create an object or an instance of this wheel object for each time it goes through this range of 4. So it's
So
just
if you were to put an I, it looked like it would be like gray. Would you have to define I somewhere? Or
uh we could
I can't tell on your screen if it's okay.
wait, what is it? I
I don't
forget how to do
think
this
you
when you
have to.
initially.
I don't think in Python you have to do a
Oh,
let.
cool.
I want to say it would just still work the same, but it's not being like
So,
accessed anywhere.
yeah, so that was my question. When you have the underscore, did you have the not accessed error? No.
Mm,
Okay,
no.
cool. Yeah, that answers my question. So I didn't know that's like a placeholder variable.
Yeah. These sometimes confuse me. But you most often see it in these iteration types where you don't actually manipulate the variable. Like I'm not manipulating any of these numbers, right? I'm just saying I'm using it as like a placeholder for counting. But like if we were usually when we say when we iterate through like for number in list, then we usually try to do something with the number plus 1, or, we're trying to manipulate that. But if we're not touching it, you can use this underscore. And Joshua has a good question. Why was the wheel put into a list? That's just how I decided to hold multiple instances of this object, because otherwise, how would I have multiples in here? I could do a dictionary, I guess, somehow, but that would be a little more crazy and not really not appropriate for this example. But this now is going to hold. So since I didn't want just one wheel, we could have just said, wheel equals wheel. But this is going to basically have now wheels is going to equal a list of wheel 1, wheel 2, like that. Of course, they're optics. Okay, so this is composition. Let me add these two methods onto here as well. This also is not going to be one of your frequent go-tos, unless if you really take the time to lay out how all your objects are going to work together. These two methods here, we have a start and a drive. Now with this start, we can see that it's returning self.engine.start. So what is this doing here? This is a function call, right? At the end here, or a method, we're calling a method.
So it's starting the engine that belongs to this class object that you're creating?
Correct.
Yeah.
So when we initialize this, it's going to automatically initialize an instance of engine, which will have this start method in it. So it's targeting the self.engine, which is an instance of engine, and then that method that's available within that instance of engine. So this is good when you want to use things also from another class without inheriting. So I could still call everything underneath this if I initialize an instance of this class into an attribute within this current one.
So this is also just like encapsulating, so you can create one instance of car and then also inherently just create instances of all of these other classes at the same time?
Correct. But these will be created and assigned to this instance of car.
Mhm.
So
To
they
a
will
certain
still be their own instances and their own, but they're very strictly tied to this car instance as well. So yes, but that is a good way to think about it. So the README goes through, how do you choose the right approach between using this type of encapsulation and, whether you're going to do a composition, which is a has a relationship, or you're going to use inheritance, which is an is a relationship.
So that's like a parent-child relationship.
Sorry, what was that?
Is that like a parent-child relationship, right? On the engine is going to be not only a car, it could be I don't know, the motorcycle. So engine will be like the parent, and the class car will be like the child.
So for this one, we're not doing a parent-child relationship because car is not inheriting anything from engine. It's just initializing an instance of engine within itself. So with composition, you don't really have a parent-child relationship going on. You kind of have a like, I don't know, buddy buddy. Like it's I don't know how best to explain this. It's its own instance. It's not being inherited. You're just setting up its own instance of that object within this class.
Still calling the class engine through
Yep.
car.
Yes, correct.
It's
So
kind of like a recipe, if I'm going to make a pancake, flour isn't a pancake, but I need flour to have a pancake, right? So if the top level thing, car, is my pancake, then the classes that has a relationship are just the components to make the pancake.
Yep, exactly. Um,
Right, thinking.
that's a good example. So we can also pass things in, right? We could have like what cylinders, and then we can do so then when we come down and initialize an engine in here, let's see, this one I think we have to add. I was not prepared for this. Let's see what we have to do. I think we have to accept in cylinders and then use it within this. Let's see if that works for passing in. We don't go that in depth in the README, but you probably want to know how to do this, right? Because very rarely are you going to have a class that you don't pass in your own parameters for attributes. So now we
what that
initial.
mean? Cylinders equal cylinders. What are you trying to do with that?
So with this, cylinders is an attribute that engine expects to be initialized. So I'm saying, okay, that attribute, we're going to pass in the value of cylinders, which is this one that we're passing in with the car initialization method. However, I don't know if this works off the top of my head, so we're going to test it just to see. So car1 is going to equal an instance of car, and then it's expecting me to pass in cylinders. We'll say this has 6. So then I expect car1 dot engine dot cylinders to be 6. Yeah, we'll see if this works. And it does. Okay, that's what I thought. So anything you want to initialize in another class you're calling and setting up in your attributes. Yeah, for now, Logan, that's a good point. I did explicitly do this, but because nothing else is being passed in, we could just pass in the cylinder's value, and engine should recognize that's the only argument we're expecting here. That is a good point. But you may have more. So you can be explicit. You don't have to. It should just know, especially if you order them in the correct order, as we always do with our initializing classes, it should just automatically assign them. I was stuck on our super init where we had everything in one.
So should I just place just cylinders instead of cylinders equal cylinders? It's kind of
Yes.
confusing.
Yeah, yeah. So for just a regular initialization of the class, go ahead. You don't have to explicitly define it like that as the parameter. When you do your super init though, with multiple inheritance, you do have to be explicit so it knows which attribute under which class it's going to stick it to.
What
But
about
not
if
for
that
this.
attribute is a string? Right now we know it's six, so it's an int. We will call it without calling it, without saying that that's an int. But what about if that attribute? It's a string. Should I place a string right next to that, right there?
Um,
Uh-huh.
you don't have to explicitly define the types of the attributes. You can if you want to accept only certain things. Like if you wanted to make sure they can only type in integers with cylinders, you can definitely explicitly define them.
Like in this case, we know it's six, but what about if it's a V6? You know,
I
so it
mean,
has a string and a number at the same time. So how would I call it from there, knowing that that's a string, not a number? I just want to make sure I'm doing the right thing while I'm doing this. I'm sorry.
so because I didn't explicitly identify what that attribute expects, I just said go ahead and take in anything that's passed in. You can pass in an integer or a string, and it will accept both. So that's where you would try to handle that. If you didn't want to do it in your attributes, like you could go ahead
Place the
and make
car.
this
Okay.
force it to be an integer if it passes in. Um, and then I would probably print type of to make sure it was an integer, but you would have to think about that and handle it. But right now, for just ease of understanding these concepts, this accepts anything that the user inputs and just assigns it to that attribute.
Thank you.
Yeah, at the top where where's that? Self dot cylinders. Uh, yeah. That parameter, you can actually just do a colon and force it to be an integer already when it passes through, and it's gonna error if you try to do like anything else, but since it says like cylinders.any, it's gonna accept any kind of data type. But you can actually force it to be like, I think
You
it's
could
like
put you
an
could
arrow or something. Like you can do integer or string, like that's what it expects to be. But if you just
that's
want any data type, then
that's where
it
you put
just
it.
by
Okay.
default is any. Yeah, yeah.
Yeah.
So you could put
Yep.
Boolean, string, anything in there. Okay. So
You could put like a whole sentence if you wanted to.
Yep. So this is where you do that. Yeah, like I was saying, I didn't really want to limit you all like that, but you can definitely do that for your own um, data validation for sure.
Like if you wanted to be fancy.
Yeah.
No, that's super helpful because usually you do like a if, you do if statements for validation. I didn't know that. I just looked it up while you were talking. That's pretty cool.
But one of the cool things about Python is that you don't have to, it's not a static variable typed language. It's very interpretive, and we'll go ahead and sort that out for you. So, other languages, you definitely have to identify what type of variable it is for everything, and it's annoying. That's why I
Yeah,
like
that's like TypeScript. I just started sampling
and C
TypeScript and
sharp. I
it
gotta
does
make
that
everything.
and it makes it's very a lot of
But that was, thank you very much, V, for speaking up about that, because that does help answer the, how do you handle if somebody's trying to type in a string or you want to make sure it's a specific type, you could definitely do that up there.
yeah, I
As
think it's
shown.
pretty important though. We're just working with numbers right now, so we cannot assume that, we don't mind working with numbers, but I'm pretty sure there's going to be a point and we're working with classes that we care about the strings, so we got to look through the strings. So I'm pretty sure we're going to need it eventually in a different class, maybe. I don't know.
So
Mm.
let's see. One issue though is well, it took it anyways. That expects it. I wonder if I have to. Maybe it did that type coercion where it changed it to an integer when I passed it in. I don't know, because it didn't complain. My only thought is if the end user tries to feed your method something that doesn't work and you don't handle it, what's going to be returned for the end user to see? Like if we limit that they can only put in integers, but this just fails without telling them why it failed. Because you usually don't give them, command line logs for them to see. They'll get like an explicit error message like, oh, cannot submit a string or yeah, letters. You wouldn't say string, they don't know what a string is. Your input must be numbers only, they expect to see that. So that's where you would then handle that underneath, or you would fix it for them, which is what I did with the int. That's getting a little more in depth though, but you do some like try initializing as this, and if it fails, then go ahead and throw this error on the screen that says this so that they understand. So that's my only concern of going ahead and just putting this in here like this. Just making sure that the end user knows why it failed. So that's something to think about too. But this is all very good questions and thought process, and definitely should be on the top of your mind in the actual field. For those who this is going above and beyond, that's okay. Just make sure you understand the composition part of this. Okay, so do we kind of understand when to use inheritance versus when to use composition? And we understand how this looks different for our setup. We're not doing a super init or nothing because we're not inheriting. We're just simply creating instances of those objects within our overall object.
Does it matter for composition if the class car was defined at the top above engine and wheel? Will it still recognize those two things?
Good
Those
question.
two classes?
So in Python and Django, when we get into that, there is some issues with using things before they're defined, but it looks like in just regular Python, this is fine. But yeah, when we get into Django and we have a database backend, then you definitely will have to, oh, you still have to enforce it. Okay. We'll read this little blurb in a bit off camera if we want, but yeah, so for this, you can define around wherever. It will find the class within this file and initialize. But when we have databases, that gets a little more tricky because you need certain tables to be defined and accessed before you can start working in them in a different table. And you'll see that later on. Any other questions on inheritance versus composition? How we initialize each of these differently?
Yeah, so for in class car for the self and cylinders, if we passed uh the k-wargs, would it still pass? Or do we have to specifically say, hey, cylinders and then engine cylinders?
So I give it specifically cylinders because I did add it as an attribute up here. If I didn't have that, then I'm sure we could just do the quarks as passing in and it wouldn't use them. But then we wouldn't be able to access them really anywhere. We have to, have them identified somewhere, which is why I have an attribute within this. The only reason we use quargs in the other is so that it could kind of pass through that middle class before it got to the class it needed to be used in. Right? Because we were passing in just a whole group of attributes to be assigned, and first one had this one but didn't have the other, then the second one had one. So it just allows that data flow without stopping it. Here, though, I want to actually use cylinders. I don't want to just have it passing through and not being used. So I definitely assign that as an attribute. And then as we see here, you can access these class attributes by just stringing together everything, right? So we said car1 is an instance of car. Well, within car1, we have engine, which is an instance of a class, right? Engine is an instance of engine. So we can access attributes within that class engine, which is the cylinder attribute. So we see how to do that.
Can you also get an example of the wheel? Because you're running, you're going through the list on the wheel. So I'm trying to understand what you're running for and for.
Let's let me make a string method here so we can.
Thank you.
Self. So we can visualize this a lot better, because if I just print out this list, it's going to be the objects, right? So we want to see turn an F string. Let's do. There's not really anything to print though. Let's give it. Let's do size. It's not. Because, so if I printed just this list of wheels without doing a string method, we're just going to see the object, right? We're going to see that string of letters that signals where it is in memory, because we don't have a string method. And this is instances of the wheel object. So in order to read objects nicely, we need these string methods. I realized I didn't have anything nice to grab hold of in here to put in my string method. I guess I could just say, instead of we'll just return wheel.
Because the confusing part is that you're going, I'm sorry, I mean, you put it as an example on the list. So I want to know, it's going through 4 in range 4. So it's going from 0 to 3, right? And if it's going from 0 to 3, what am I actually reading and what am I keeping on the list? If that is your example.
Yeah, so it's going from 0 to 3, and each time it does that, it's going to create this wheel object. So it's saying initialize a wheel object every time we go through 0, 1, 2, 3. So this is just a way to iterate up to like 4 instances, and we're saying do this each time you're iterating along this range of 4. So create a wheel object. My string method is just going to say wheel now, so we don't see the ugly location. So let's just print wheels and see what this shows us here. It still did. Why did it not do that?
But it's, I mean, until you do something with it, it's just creating 4 wheel objects.
Yes, correct.
Okay,
So
and until we actually do something with it, but it's actually creating those wheels. It just looks weird. It's not like it.
It's a memory
Oh,
position.
okay, yeah.
yeah, I'm trying to
Yeah,
get
so
the
it's
nice.
creating 4 objects, but if you were to like name the wheels like wheel 1, wheel whatever, then it should come out like.
Yeah, you would probably you'd make this a lot more involved, I guess. So if you wanted to do something like that and name everything individually, This is gonna be a little more complicated, but how I would handle that is I'd have a create wheels, oops, method here, and I would, oh, I'd have to logic through this. I can't just whip this up. I'm horrible at that, but I would create a wheel and create wheel. I don't know how to do the name. We could do it all in one, but we could do kind of this concept, and I don't want to waste too much time trying to logic out how to give it the names, but create a wheel, and then we can maybe say like for wheel in, oh, so this will be list of wheels equals that. So it's going to create all those objects, and we're going to say for wheel in list of wheels, maybe like, I don't know, do something. So I do like this method here, and then I can call create wheels, usually self dot, create wheels up here. So that whenever this object initializes, instead of like just assigning a value, it will actually run this method and assign it to that value.
But we'd have to change the placeholder to I, so we can actually iterate the up at the
Well,
top wheel for I, at very top
very tough.
list of wheels. Or sorry, list of wheels. We have a
Oh,
placeholder
this,
there. Yeah, would we have to change that to I, or would it just? Because then if we call for wheel in list of wheels, print
so what this would
wheel
be is this would be
I.
this.
No.
You'd get,
Okay.
this is what list of wheels would look like. And then you could go through and, go through each one of these objects and maybe like just grab if it had that's why I was trying to give like a name or a size, I guess. I don't know. But there's different ways to go about this. You could try to find an attribute to grab out of there and just assign a value. There's a whole different ways you can figure out how you want to handle seeing a nice, pretty list of the wheels instead of just objects. But yeah, I don't know why the string value isn't working for those objects.
Would it be because you got to put in the F in front of it?
I'm not I'm not using any variables with this though.
Oh, gotcha. Okay, that makes sense.
I was just giving them all just wheel.
Oh,
I don't know. I can play with that more and figure it out. Oh, wait. So string self, let's say Jose says return if there self dot wheel maybe. But we don't have a wheel attribute. So
okay.
yeah.
Gotcha.
That's why I'm like, this is dumb. Makes it very hard for if I had size, I'd probably return an F string saying wheel and then like size, I don't know. Okay. Something like that.
Gotcha.
So also, why am I able to just do this and not passing anything into this method?
When you mean able to do this, why is that line working?
Yeah.
Or
Yeah. Why am I able to grab this value of this attribute?
because it's still a parameter within the init function. I just don't know why.
It's an
Yes.
instance attribute.
Correct. It's an instance attribute. So it is something we've identified as an attribute to this instance. It is available everywhere. Everywhere, in every function. I never have to pass it in because it just exists in this instance of this object. So I can always use self dot whatever attribute everywhere without passing it in. Yep. All right. So any other questions on composition can get a little interesting. This was a not great example for see. I wish we could see a nice list, but that's going to take a little more thought on my effort. But for now, it's just making a list of wheels. Oops, I want to get that back though. Shoot. We're going to take all these out. Take that whole screen method out because that doesn't work. This though. So it's just creating a list of those objects to access. So we could, if wheels had attributes, like if it had that size, we could definitely do, okay, take this instance of car that we've created here, grab the wheels. Ooh, how do we do grabbing the, that's a list, and then we could probably grab the first value in the list, size. So, you know, you'd access it kind of like you would a regular list, but then you can grab, so I'd grab the first object in that list and then get its size attribute. Hopefully that did not confuse you all a bunch. Cylinders is a much easier example because cylinders is just one value. It's not a list of multiple values. It's just
We have size. The color of size is not calling it. How will you call it? So size is supposed to be blue, right?
yeah, it's just because I haven't I didn't put these back in. So size equals size. So then if we do that, we're going to have to pass in, so everyone would get the same size pretty much. I'd give them all like, what's a decent size wheel? I don't know what size wheels are. Are they 28? Does that sound like a 28 inches?
Probably 16 is pretty standard.
16?
Yeah.
Okay, so I'm in the south. We have
28 is like a monster truck. But
Yeah, 28 would be a
Yeah.
monster truck tire.
okay, there we go. 16. So this would create a wheel with the size of 16 for each. We can pass it in as well. You know, we can pass it in as a I know, rabbit hole for sure. These are all the like what you can do as long as you understand how these initializations are grabbing values and how we're calling other instances of classes and also passing in values. This one's just explicitly making multiple instances of this wheel object with 16 as the size. So then if we did this, this should work. Let's see. It does. So we could see it made 4 different wheels with the size of 16. I grabbed the first wheel in the list and asked for, whichever size was associated with it, what value that attribute held, and that was 16. All right. These are the kinds of things you will, you know, work on to understand more. But I just want to make sure we understand, instead of having like a super init for our composition, we're just simply assigning them to the attribute values. And then to access, we would string through these instances of these objects. Okay. Next example, we're going to just really touch on this real quick because I think we learned this pretty good this morning. We'll just take that out. Actually, we could just keep it. Nah, I'll keep it there in case there's a few more instances. So now we have our animal, dog, cat, duck. A few of it looks like dog, cat, and duck are all inheriting from the animal class. They're not doing a super init because there's no attributes associated with any of these. They simply just have these methods, and they're all named the same thing. So this is kind of like what we learned earlier about how the child class method is going to kind of override everything else. The official name for it is, bring this here, polymorphism. So it's the ability to have the same method call in a way that's appropriate for their individual types. So we can identify how each of these different classes handles the speak method. So even though they inherit speak from the animal parent class, the child class, if it has its own speak method, this will be what it uses. Because for methods, the class will look within itself first for the method and run it. If it doesn't find it here, it will use the parent method. I don't want to scroll down. I shouldn't have copied all this over. If I were to call this dog speak, what do we expect it to say? Scroll down. I don't even want to type in there. Woof. Right. So we expect that to say woof because it's going to look within its own class first for speak. So dog, speak, it has its own method. It will call wolf. Cat. What if we did cat dot speak? What would the return be there?
It would be
It's
meow.
It'll be meow. Yep.
Right. It would be meow
um
because why is it
sorry.
not using, it doesn't have one,
It's gonna
right?
just inherit from animal.
Exactly. So cat, we come to the cat method or cat class here. It looks inside, says there's no speak method. So let's look at my parent class animal, see if it has one, and it does. So it's going to return meow. And what about duck? What is that going to return for speak?
Affleck.
Sure. Yep. It's going to use quack because it has that method within its own class there. So just reiterating what we learned this morning. As we can see, it's really useful to like, this doesn't make sense. We'd probably have like a generic, I'm speaking just because an animal doesn't have a specific sound. And then we would have each of these methods underneath each animal, overriding it to be more specific to its class itself. All right, any questions on this polymorphism? You don't have to remember the word. I'm going to show one more tip and trick with this before we go over what we're going to be doing for the rest of the day. Okay. So the last thing, I'm trying to see if I like this example the README has. So we've seen a lot of times in my examples that I've been doing a lot of identifying a base class and then just writing pass underneath, right? Like I did for vehicle. I didn't really have anything that I wanted to use in that class, but I wanted to have it defined as a separate name just for that separation of it's going to bother me. There's a different word, but we'll use concerns. I'll find it while we're working on stuff. But the separation of concerns, like I want to make sure vehicle is its own thing and clearly defined, just in case we do stuff with it later. But I had nothing going on in it. I just put pass. So let me take out this from the README here. We're gonna just get all that gone. Okay. So in order to make that a little bit more like proper Python and handled in a more solid way, we will import this abstract method and ABC class from ABC. So ABC, as we can see when we hover over it, it's a helper class that provides a standard way to create an abstract base class using inheritance. So as we can see, the shape, this would be our base thing, right? Before I would have had nothing here. It would have just been a shape. I would have just had like a pass underneath the init. Instead, we're going to have this shape class inherit from a built-in helper class called ABC. That's abstract base class. Doesn't matter what it has behind the scenes. It's just helping us set up this base class that's really just here for organizing everything. And then we have this method called area, which we put pass under. Simply adding this here so that we're just intending to overwrite it later in child classes. So we're that polymorphism at work, but we actually don't have anything we're going to do because there's no way you can write an area function that covers all shapes, right? But sometimes you might want that method in there just for organization and for continuity of all these design concepts. So you can do this. What is this called? When I do an at method name up top?
Decorator.
Yep, a decorator. So we can use this decorator that's built in to Python called abstract method. And it just indicates it's an abstract method that really doesn't do anything. It's just used to be a placeholder, basically. So this shape could absolutely 100% be written just like this shape. This is fine. It could be written like this. However, it's more standard best practice to use these abstract class and abstract method to just kind of help define that this is just an idea, I guess. Not really doing anything for us. In turn, we can see down here that nothing changes with how so we're inheriting from shape, but because it doesn't expect any attributes to be passed in, we don't have a super in it. So we're not even, I mean, it seems silly that we're doing this, but I have an extra example I can walk us through after lunch that will kind of show a better use of this abstract method and class. But for now, it's literally just an organizational placeholder. We're not really inheriting anything from shape. We're just saying, hey, it's a shape. We don't have any attributes or methods underneath this. All right. So just kind of something nice to know that you can do this and you can define these abstract methods, which will be overwritten by your polymorphism ones that are specific to your child classes. That's all that is. Don't worry if that's not a go-to for anything. It's kind of a good to know because like I said, there's absolutely nothing wrong with just doing that. Any questions on this abstract method?
I had one question.
Mhm.
So, are all of these code samples we've been going through, are they going to be shared on Slack or?
So let's see. So the polymorphism one, the ABC method
Oh,
is in our README. So is the polymorphism and how those method, let's see, in the shape. The only thing that's different is I went a little more into this one, so I will share that.
oh,
What
okay.
we added there. Because I think we added on, yeah, we added on passing in parameters to these instances of these objects. Whereas the README does not pass in anything, it just instantiates those objects without any attributes being passed in.
Okay, awesome. Thank you.
Yep. All right, so I will share that. Otherwise, the rest of these should be direct excerpts from the README, and I think that's all you'll need to be able to use them. if you want. Any other questions before I stop sharing and we start talking about the rest of the day?
Yeah, can you go over again what from ABC, import ABC is doing?
Yes, so these are built-in classes and methods in Python. So anytime something's built into Python, we can just import those methods, functions, classes, whatever from Python. So we're saying from ABC, which is a module in Python or a library you could think of too, import this class and this method. So
I
then
found
we're
uh,
able,
I found the name of that thing you were looking for.
oh, what is it?
Single responsibility principle.
Yes, yes, the single responsibility. That's what I for some reason I thought it was separation of something, but single responsibility. That's what I was thinking
You
of.
were close. You.
I knew it was somewhere in our readmes, I'm sure, but I could not find it. Um, but back to this. This is just an import statement to use these, and you just plug them in like you're inheriting. This is a class, as we can see when we hover over, that we're inheriting. It's built into Python. And then this abstract method we use as a decorator that we're inheriting or importing from Python. Yep, we just use it as syntax snippets show us to use it. There will be a lot of things we will import from Python throughout this course, so it's good to get used to accessing different libraries and modules in Python to import different things. But we will share them. I'm sure there's a list somewhere of all the things you can, all the modules in Python. But all right, any other questions, last minute questions before I stop recording? All right, I will stop recording.